Okay, there we go. We must get started. Good evening, everybody, and welcome to our main meeting on Wednesday, the 19th of July. First things first, the disclaimer, and I got it here somewhere. Okay, please note that all our meetings are recorded and made available to the public for viewing on our YouTube channel. By participating in the meeting, it is understood that you have accepted these terms. And that's it. So tonight on the agenda, I guess Peter's going to go first. So his topic is RF design basics regarding the Phoenix. Um, then Eric, he's going to present something on the LobsterCon and our field day score and possibly getting a call sign.
Oh.
And then um, after that, we're all done. Uh, we can have a show and tell or questions and whatever. Okay, go ahead, Pete.
Okay. Oh, there we go. You can see that?
Yep.
Okay. All right. Okay. This is on the, I know Ken mentioned on the Phoenix, but this is actually just going to talk a little bit about design basics for a receiver and make references to the Phoenix where appropriate. Um, there was a couple of ways I could have gone with this, and I just decided to really go basics on this one. And my plan is maybe something a little bit more practical on the same subject, but a more practical perspective as we move forward. So anyway, we'll see what happens. Okay, a lot of the presentations that I and others here in SOAREX do result in rabbit holes. We tend to think of them as negative experiences, but in reality, they offer the perfect situation to learn. I tried to minimize the depth of the rabbit holes I was going to encounter while putting this presentation together, but that proved rather difficult. Having said that, I hope that this presentation will generate conversations, questions that may drag me into yet another rabbit hole, or even better, someone else to join me on that journey. Regardless, feel free to ask questions and don't feel obligated to join me down that rabbit hole. Okay, there are many factors to go into the design of a receiver, and I'll cover some of them tonight. Examples, selectivity, sensitivity, image rejection, and dynamic range. Okay, the super Het receiver is a type of radio receiver that is widely used in radio communication systems. The term super Het means higher than the frequency, which refers to the process of converting incoming radio signals into a fixed intermediate frequency, IF. The super Het works by mixing the incoming radio frequency signal with the local oscillator to produce an IF, and the intermediate frequency signal is then amplified and filtered to extract the original modulating signal. We all kind of know that, but I kind of had to start somewhere. The advantages of the super Het receiver include its high sensitivity, selectivity, and stability, and the ability to use a fixed IF frequency allows for better filtering and amplification, resulting in improved performance over a wide range of frequencies. One of the major drawbacks of the super Het is the potential for image frequency interference, which occurs when a radio signal at a frequency that is the same distance from the LO as the desired signal is also amplified. And this can be minimized through careful frequency selection and filtering. Okay, successful design of a receiver front end. Okay, designing the front end involves consideration of various parameters and components to ensure optimal performance. And here are some of the key steps and factors to consider in the design process. System requirements. Define the system requirements such as frequency range, bandwidth, sensitivity, selectivity, dynamic range, and these specifications will guide you through the design process. Architecture selection. An example here would be the super Het or a direct conversion or even a regen receiver. Noise figure and sensitivity. Minimize the noise contributions from components like amplifiers and mixers. The front end gain. Determine the required front end gain based on the system's overall gain requirements. Filtering. Use appropriate filters to provide selectivity and reject out-of-band signals. Consider using a combination of low-pass, high-pass, bandpass, or notch filters. And in the case of the Phoenix, we use QRP filter modules, low-pass and bandpass. Include low noise amplifiers at the front end to amplify weak incoming signals in order to maintain low noise figures. Choose an LNA with a high gain, low noise figure. And in the case of the Phoenix, we use the LT1253 chip, which has 2 op amps in the one package. Mixer design. Select a mixer that meets the desired specifications for frequency, mixing, linearity, conversion, gain, and isolation. And use a double balance mixer to suppress unwanted spurious responses. And in our case, in the Phoenix, we use a couple of the 612s. LO design. Design the stable and accurate LO source to provide the required frequency conversion. Use a voltage controlled oscillator, which I've never actually played around with those ones, or a frequency synthesizer. And in the Phoenix, we use the SI5351. Impedance matching, favorite topic off and on. Ensure proper impedance matching throughout the front end to maximize power transfer and minimize signal reflections. EMI and RFI considerations. Incorporate shielding and grounding filtering techniques to mitigate electromagnetic interference and RFI from internal and external sources. In the Phoenix board, we've made provisions on the PCB to install shielding if we find it necessary. We put those solder pads all around the critical circuits. The PCB layout. Pay attention to the physical layout of the components to minimize parasitic effects, signal degradation, and crosstalk. Follow best practices for RF layout, such as maintaining proper trace widths, separation, and grounding techniques. And that we did do with the Phoenix. The 12 volt a little bit larger, RF a little bit smaller, just depends, and try to keep things separate as possible. Testing and verification. Perform thorough testing and verification of the design front end to ensure it meets your specifications. Use appropriate test equipment and measurement techniques. Boy, oh boy, there's a topic. And to validate the performance. Remember that it's crucial to simulate, prototype, and iterate on the design to optimize performance and achieve a successful outcome. Use LT Spice and break down circuits to their basic form and develop proof of concept boards. And looking at some of our older D612 boards, you see all kinds of daughter boards and everything that's been spliced into the existing circuit board. Okay, we'll love this one. Receiver sensitivity again. Now the math. There's a lot that goes into receiver sensitivity, and it's math, and it's a big rabbit hole, but not today. Instead, we'll just go to slide 5. Sensitivity is the minimum power level at which the receiver is able to clearly receive the signal being transmitted. In the case of the Phoenix, in the past, I've stated S3, but in reality, it's more likely in the area of S4. S3 would be possible if it's a CW signal and you're straining to concentrate and of course no one's home. Now I have noticed a difference between the proof of concept board and the Phoenix board. I'm not too sure if it's something in there, but like relay contacts that have slightly degraded the performance, or the difference between characteristics of the mixer chip itself. I did notice when I was swapping mixer chips around the other day on the proof of concept board that one actually did perform better than the other. Limits the sensitivity. Thermal noise. All electronic components generate thermal noise, which is a type of random noise that is proportional to the temperature of the component. And that noise, as we know, can limit the sensitivity of the receiver, especially at lower frequencies. Now, the Phoenix has minimal components between the antenna and the LNA. I believe it's just a cap and a resistor. I believe that amplifying the RF immediately through the use of an LNA is the best way to go. At some point, I think I'm going to test that out. I think I'll develop a couple of boards, one where the bandpass filter is in front of the LNA and another one where it's behind the LNA, and just see if there is a difference in the performance. The first filter stage will come after in the case of the Phoenix, the first filter stage is after the LNA, and I'll briefly come back to this later. Interference from other sources, such as transmitters close by, that can raise the noise floor of the receiver, making it much more difficult to detect weak signals. Nonlinear distortion. Nonlinear distortion occurs when the signal level is high enough to cause the receiver components to operate in a nonlinear region. And this can result in signal distortion and induce additional noise into the receiver. Nonlinear distortion can arise from various sources in a receiver. Example, amplifiers, mixers, local oscillators, other components in the receiver circuitry such as diodes, transistors, I guess pretty much everything can exhibit nonlinear behavior. Simulation tools can be used to model and analyze the nonlinear behavior of the receiver's components and evaluate the impact on the system performance. Full disclosure here, that I've not done. I've not done any kind of modeling with LT-Spice for nonlinear behavior. Maybe at some point I will. Impedance mismatches. The impedance mismatch can reduce the amount of signal power that's transferred from the antenna to the receiver. And receiver bandwidth. Basically, narrowband receiver can be more sensitive to weak signals than a wideband because it can filter out the unwanted noise. Contributing noise factors. Transmission lines and connectors that connect the antenna to the first amplifier stage can be a large contributor to overall noise using lossy coax or connectors. Now, the red circle depicts on our proof of concept board here on the right here. There's the input to the LT1253, and then there's the antenna jack. So we put everything nice and close there. Oh yeah, and you can see over here in the design for it, the input of the first stage of the LNA only has the resistor and the capacitor. On the Phoenix board, well, we kind of got away from that. There's the antenna input there, and then the receive follows this trace all the way over to the LNA over here. And that was due to, if we moved the relay and everything over to here, then we got a much longer transmit trace on the board. So I think it's still a debate to have with Dave over this, but anyway, that's the way it is now. There is, sorry, where are we here? Okay, the potential sensitivity it's possible to achieve with a given noise figure is determined by the IF bandwidth required. For example, CW in sideband, choose an IF bandwidth just wide enough to pass that desired signal, and this maximizes the noise to signal ratio. At the moment with Phoenix, we have a 4 crystal IF. Early on, I was beginning to think that maybe we should have gone to at least 5, but somewhere along the way, I'll start playing around with crystal filters again and go up to the, with more crystals in there and see how they look. The receiver sensitivity depends on the noise performance of the earlier stages. If amplifiers that have a high noise value, or if the filter stage before the amplifier has a large insertion loss, the overall sensitivity will be degraded. And that's why we put the 1253 ahead of any filtering. Okay, here we're doing a comparison between the Park DCR and the Phoenix designs. Now, the Phoenix design takes care of 3 points made earlier. The thermal noise. The LNA is before the bandpass filter. So if you look on the DCR, the antenna is going right directly into the bandpass filter, and then right directly into the 612. Which means in the case of the Phoenix, we've utilized matching transformers, and in the case of the DCR, there is none. The receiver bandwidth we took care of with a crystal filter designed around the single sideband signal. Now, having said all this is not to criticize the DCR. It works very well. The Phoenix receiver is just an evolution to the DCR. So, well, how to improve the sensitivity, a bit of a recap here, and with a couple of additional points. Using low noise amplifier can help increase the signal to noise ratio at the input of the receiver, and thereby improving the sensitivity. Adding a narrowband filter after the LNA can help reduce the noise and interference, thereby improving, again, sensitivity. Antenna design, that can have a significant effect on sensitivity of the receiver. Of course, using high gain, high directivity antennas will help improve the received signal level. Impedance matching, that's very well, as we all know, that's quite important for the receiver. Is critical for maximum power transfer. Low noise power supply. We've used an awful lot of caps to clean up any of the power line traces to the point where I was getting tired of installing 0.1 caps. I lost count of how many there are in this particular design. But if they work, right? That's what we need. Multi-stage amplification. Using multiple stages of amplification can help improve the sensitivity. Each stage can be optimized for maximum gain with minimum noise to improve the overall signal-to-noise ratio. Presently, the Phoenix is set at max on the LNA. We did originally think that the first op amp would have pretty close to full, and then the second stage, not so much. In reality, though, I've got them both bumped up them to pretty much max. And then once I get the signals or the radio stabilized, then I'll start doing some testing as far as, backing off on the gain a little bit and just seeing how it reacts to the noise levels. And then, of course, there's various signal processing techniques such as DSP, error correcting coding, and that sort of thing, which we don't use at all. Image noise. I spent an awful lot of time on this topic. In a super het receiver, image noise refers to a specific type of interference that can affect the quality of the received signal. It occurs due to the mixing of the desired signal with a spurious signal during the frequency conversion process. The image noise problem arises due to the mixing process in the mixer stage. In addition to the desired signal, the mixer also produces the sum frequency. And if there is another strong interfering signal present at the sum frequency, it can mix with the LO and produce an unwanted signal at the RF frequency. And this unwanted signal is referred to as the image signal. Now, it's important to design a receiver to have good image rejection performance. And this can be achieved by using high Q bandpass filter at the input of the mixer to reject signals outside the desired frequency range, and by carefully selecting mixer frequency to avoid mixing with unwanted signals. And then there's just a quick diagram of, this is what your antenna is receiving in there. Then your first stage of filtering, and you're basically mixing out the, there's where your image frequency would be. Your mixer outputs here with all those frequencies in here, then your IF filter is tight enough that it rejects it all. And you're left with just the frequency of interest. Now, this diagram here is is what happens if you don't have the filtering and the image frequency gets through. And basically, it's just mixing there close by without any kind of filtering, and it's the IF filter is wide enough that it actually gets through, and then you end up with both of them on the output of your IF. The receiver selectivity refers to the ability of a receiver to separate and isolate desired signals from unwanted signals or interference. In other words, allows it to tune to a specific radio frequency while rejecting or minimizing signals on adjacent frequencies. The selectivity of a receiver is typically determined by various filters, and these filters are commonly implemented by using caps, inductors, and ICs. And the types used are, of course, the bandpass, IF filters, crystal filters, etc. And the selectivity of a radio is usually specified in terms of its bandwidth or the ability to separate adjacent frequencies. Now, the block diagram we have here shows the blue layout, the layout for the Phoenix receiver, and the yellow represents where you could make some improvements to the radio's selectivity. I've added in a bandpass filter before the RF amp, which goes against what I was saying earlier. But as I said, going forward at some point, I think I'll try it all out and just see kind of how it works. But after reading an awful lot on the subject, it seems that the best way to go is to have a bandpass filter after the RF amp. Anyway, you can add another bandpass filter after that last mixer, and then you can put an audio bandpass filter in there as well. Dynamic range of the receiver is defined as a range of RF input levels over which the radio receiver can successfully receive those signals. Receiver's dynamic range is significantly dependent upon the mixers and amplifiers in the design. Dynamic range can also be limited by both active and passive filters in the signal chain. An automatic gain control AGC circuit at the front end of the receiver can be useful in avoiding signal saturation and spurious signal generation. We do use an LNA in the Phoenix front end, but we have not incorporated an AG circuit, nor have we really discussed it, but it's probably not that far down the line for the next generation. Okay, design for optimum dynamic range performance is not an easy task. To design a highly sensitive radio receiver that also has a wide dynamic range. RF circuit design requires careful balance of many different parameters to obtain optimum performance. And to achieve required level of performance, a number of methods can be used. Front-end noise performance. The RF circuit design of a front-end stage of the radio is the most critical in terms of noise performance. It should be optimized for noise performance rather than gain, which goes back to what I was saying earlier about the Phoenix, where we've, at the moment, the op amps are adjusted for full gain, but recognizing that we're probably introducing a little bit of unnecessary noise there. Input impedance matching is critical for this. Components using an active device should be selected for the noise performance. Front-end output capability. The front-end amplifier should have a relatively high output capability to ensure it does not overload. The RF design must provide sufficient output capability so as not to generate high levels of noise. Again, don't set them up max. The high-level mixer operation is one of the key components to ensure a good dynamic range and overload performance. The design of the radio should ensure that the mixer is not overloaded. And the use of a high-level mixer, like one designed to accept the high-level LO. In this way, it can tolerate high input signals without degradation in performance. The receiver's later stages. Ensure later stages of the receiver can tolerate the level of signals likely to be encountered when strong signals are being received. It's relatively easy to calculate the maximum signal levels that occur in each stage of the receiver and then ensure that these can be accommodated by the design. In these stages, the noise performance is not as important. And the good use of an AG system in the design will help prevent overloading and generation of unwanted spurious signals. And these are just a few issues that should be taken into consideration during the design process of a receiver. Some, of course, we did consider doing the D612 and the Phoenix, and some we never thought about until now. Okay, in conclusion, I found that taking on a venture such as a transceiver a most rewarding project. It's a natural project that can easily divide into two and allow for taking on a partner, which really made the journey far more enjoyable. This one project has been the genesis of several presentations and learning opportunities over the last couple of years. And as a home brewer, it doesn't get much better than that. The project started out as the D612 transceiver, where two main versions of the circuit were developed and built. It was met with some success, but further work was required. And after a pause during the COVID days, the D612 was revived and undertook further development, but it quickly became the Phoenix. Dave OOI took on the transmitter portion, and I took the receiver. And as time progressed, I quickly realized I got the better end of the deal, as the transmit portion was far more problematic. And having said that, while putting this presentation together, I do recognize that the various concepts that go into a receiver are far more complicated than I first envisioned. Details that I now know and talked about here tonight can and should be looked into in greater detail, incorporated into the design. Once you're in this deep, it really is not that much more work to get better performance out of the design. We haven't even finished this Phoenix project, and I'm already thinking we should have done this and we should have done that. So starting out with our DCR project and then understanding those concepts will lead the way for designing more advanced receivers. Now, what I've learned from participating in the D612 and the Phoenix project, better understanding and undertaking of more advanced LT SPICE simulations. Every circuit in the Phoenix and D612 has gone through some LT SPICE simulations. Further ability and comfort in using KiCad. Fully developing the project to now include Gerbers, drill hole files, understanding better the ERC errors, and just better way of laying out your various circuits in KiCad in a much more understandable way. Learning how to mill circuit boards, and then of course the flat cam and candle programs that go with that. And a way much better understanding of the receiver circuits and the whys you do this and the why nots. And of course, I learned to better use and understand the limitations of my test gear, the scope and the spectrum analyzer in particular, which is an ongoing topic, isn't it? Here's some references that I got. Quite a few references I've forgotten, left out, don't remember. There's quite a bit more, but these are the ones that I can remember. And down at the bottom, I put down Chat GPT, and the reason I did that, there was a couple of concepts I read several books and then doing some Googles on the subject, and I just for fun tried Chat GPT and just posed a question in there, and it actually came out and it kind of helped clarify a little bit some of the points. So it might be another useful thing. It also helps though that you kind of know pretty much the subject, so you can tell if you're being led down the garden path by an incorrect write up from Chat GPT. Okay, that's all I've got on this, Ken.
Okay, very good, very good. I've got the first comment. You had mentioned the bandpass matching the 612. I'm working on it so that the output of the bandpass matches the input of chip. So it's going to be.
That's right. I forgot about that, Ken. That's a good idea. Just rewind the output of that bandpass filter to just go. Okay, there you go. Good idea.
Yeah. Well, actually, I'm not rewinding it. What I'm doing is I'm testing on the SNA to get the frequency set on it, and then I'm having the actual primary winding going directly into the chip.
Okay.
Because all the frequencies, I worked it out that the impedance on the output of the bandpass filter is give or take around 1500. So it should work out.
Okay, that's good.
And I should, I don't know, probably after our camping trip, I'll get back onto that thing. Anyone else? Comments, questions? Okay, very good, Pete. That was great.
Okay, and I just had a message from Dave. He says, "Tried joking meeting." I guess he means joining. Signal here is terrible. Send my greetings from a campsite just outside of Quebec City, and I guess it's not too clear. But anyway, that's what he's looking at right now.
Oh, I saw some mosquitoes there. Okay, next up on the agenda is Eric. You want to take it away, Eric? Hope he's there.
All right. Hopefully you can hear me.
Yep.
Let me start up sharing here. Should be good to go now. Share this whole window. That's visible. Hopefully. Yeah. So yeah, this is from a variety of sources. So they're not always full screen. I apologize for that. So if you're looking at this, it's probably really tiny, but there's only a handful of these. Like I said, I grabbed some from Dave, some from others that were there as well, shared amongst everybody at the end. So anyway, roughly in chronological order. So this is our arrival. I think it was on the Thursday. No, this is actually Friday morning. We arrived on the Thursday, but I guess didn't take too many pictures. But Friday is when most people really started to pile in. I'd say there was maybe about 20 or 30 or so when we arrived on Thursday there. So this was LobsterCon 2023. My third time attending. I was there in 2017, 19, missed 21. Hard to cross the border that year, but I generally go every other year because I've got another commitment that I go to on even numbered years. So Last 2 times Sandy came with me. This time it was Dave was my accompaniment. So and that gets relevant a little bit later on, as you'll see. So fun event. I'd say 80% or more social, 20% radio related. So good event, about 11-hour drive from the Toronto area. So if you're thinking of going to it some year, it's not too bad. Can be done easily in a full day of driving. On the way back, we took 2 days to get out there, just so you're setting up, in daylight and arriving at a civilized time. I think we rolled in around 4 o'clock in the afternoon, so plenty of light. So yeah, that 10 by 20 shelter that you saw that was the first time that had been erected. There was some very, ratty thing that was up there the first year I went back in 2017, but Sandy and I, amongst others, donated to make it happen. So this is the first time it was put up and worked well. That's it underneath. You don't see much in the way of precipitation because we didn't get much, which was nice. But we were prepared for it and gave you a little shelter from the sun. It was pretty humid, pretty warm. There were reports of lots of mosquitoes before we arrived, but it wasn't really too bad. A minimal amount of bugs juice, and you were good. So seated in the chair there in the yellow, fellow named John Turgoose from the Kingston area. Him and his wife are regular attendees. They were the only other 2 Canadians that were at the event. Ultimately, I think the head count was upwards of 70 or so by Friday afternoon, Saturday, the main 2 event days. So, but lots of camaraderie, lots of food. This was our little camp out, little bug house. So the first Friday night there was a pig roast. So that started on Thursday, actually, in the very late, around probably 11 o'clock or so, that we slide the pig into the makeshift roaster. So whole 175-pound pig that we ended up having on Friday night for supper. But this would have been Friday morning. Bit of breakfast there, pancakes and eggs and bacon, all that. So, it's done in pretty good style, Dave and I in that picture. So there's a picture of our Dave and I's campground in the back. Put up a little patriotic flag there, and you can also see the person who was doing the fox hunt activity had a demonstration station there to see what the actual fox transmitter marker looked like, and a few show and tell things. So we did that on Saturday morning. There's some pictures later on. So there I am with handy talkie on hip. Actually used it a fair amount. There was 1 or 2 others that were using it regularly, just to whatever idle chatter throughout the event. Didn't really become necessary per se, but saved a few footsteps here and there. That's the pig roaster that I guess while it was roasting on Friday throughout the day, it was 16 hours, I think, that poor little piggy was in there. So another view of our camp. So Dave and I went around to various people that had equipment set up, very modest. Most of it was QRP. There was a little bit of 100-watt stuff going on, but that was, I would say mostly QRP gear. That's really what LobsterCon is focused on as far as the people that go to it. So I'd say maybe a dozen or so stations akin to this that were set up. So that's John from Kingston working on his Elecraft, I believe, as a K2 maybe. This crank IR antenna looks really nice. He's brought it before. I think he brings it every time, but he says that's about where it ends. It looks nice, but he says performance ain't so great. So anyway, This is a fellow who's running the fox hunting. He had I'm not exactly sure what he was working with there. I never really peered over his shoulder. That somebody on the meeting here might be able to comment if they recognize what we're looking at there. But even zooming in, I can't quite tell. I looked at it earlier and was unable to determine what it was. So, other than you've got a whole box of crystals there, but
Yeah, it's a rock-bound unit of some kind.
there's actually a video here. I don't know if it's coming through or not, but
That's a paraset, Eric.
okay, all right. Behind enemy
So,
lines.
yeah, exactly.
Did that?
Well, you were in the States.
Did that video actually play? Did you hear some of that?
I didn't hear. I saw.
Oh, but it was moving. Yeah.
The lag was
Yep.
very severe, Eric.
Yeah. Okay, I figured
There
as
was a
much.
little arrow spinning, and that seemed to be the movie.
Yeah. Okay. All right. Well, it wasn't much. You heard a little bit of CW happening in the background there, but there's Rex in the center there with the gray cap. He's the organizer of the event. This is year 24. Next year is the 25th consecutive. I don't think he's missed a year even throughout COVID. There was a dozen people that still came out that were, I guess, local to the area that didn't have to cross state lines. Fellow with the gray T-shirt, I may or may not recognize him. KD1JV, Steve Weber, wearing the arm sleeve there, but known for a few things, I guess. The QRP transceivers, right? I think he made Hendrix kits back in the day. Does things for QRP guys, others as well. But anyway, Steve Weber. So he was one luminary, I guess, in the QRP world that was there. Who's not pictured in any of these, I don't think. Dave was remiss. I told him after we left the event, you know who that was? It was Dave Benson, K1SWL, I believe, inventor of the Rockmite, Small Wonder Labs, and all that. So he was there, but I don't think he appears in any of these pictures, unfortunately. All right, so where are we here? Yeah, hello.
Yeah, it's a good thing that Dave didn't recognize him because he would have yacked his ear off the whole weekend.
I'm sure he would have. Yeah, I'm looking through here just to see if I see him in the background or any of these pictures, but I don't think so. He was actually he's very quiet. Like you almost didn't hear a word out of him. Very quiet guy. But right in front of us there in the blue shirt is Uncle Cy, the LED guy. If you guys have been to FDIM, you'll have recognized his presence. So yeah, this back in our screen house, I guess, on Friday night or whatever, enjoying some revelry after a day of hard work. This would be, I guess, Saturday morning. Rex offers a coffee and donut breakfast most mornings. The donuts just get staler and staler as the weekend goes on. But hey, what do you want? They still taste great. Everything tastes good out in the forest, right? Everybody knows that goes camping. So, so this is us. We set out early Saturday morning to find the foxes. There was one practice station nearby, and then I think there were 3 actual hidden foxes that we went and saw. So a new activity. I don't think I've ever really done that with these particular receivers. It was kind of a learning experience there as well. The fellow who was running it gave had a few papers there and articles from magazines explaining how these antennas worked. You listen for the nulls in the signal, basically. So you're sweeping it around, holding it vertical like that, and when you hear the signal disappear, well, that's the line that you're in. So a little bit of theory learned. In the meantime, there's Dave getting his ankles bitten by mosquitoes and finding the fox in the little plastic tub there. They weren't really too hard to find. Punching our cards, verifying that we had actually found them. So, three of us that walked around. Fellow in the middle was Jeff. I forget his call, but anyway, trying to throw a few youth that were also participating off the trail. I tucked the marker under my shirt and said, no, it must be another way. So don't think it worked. I think they'd already found it. But here's another modest station fellow with his 817 or 18 set up by his Airstream, working away. I wasn't sure what the story behind this man was. Never really got an answer to that. But Lobster Com, I guess that's his ham van, much like Rex in the past has brought his hambulance or what have you. So once in a while you do get vehicles that go up. There's our cards for the event. I did purchase one of Steve Weber's transceivers. This is his latest. Has a little OLED display on it. This is actually one step behind the latest, which is still in production. So he had this one, I think it was the only one that he had. And, so I purchased from it at a steep discount. I think there's only a minor difference. Might be not selectable bands. I'm not sure. Can't remember off the top, but anyway. This was a raffle prize, so I forget who won this, but just kidding. I think it was actually for sale. I heard afterwards, but somebody was actually operating with this, obviously, while we were there. But then apparently, I don't know, there was no price tag on it. But if you wanted a nice full-blown radio, there you go. Not QRP. There was a bit of a swap table set up. People selling things. I don't know. Various bits and bobs. There's a whole bunch of QRP Me things in the box. That was Rex's stuff that he was selling, his Me squares and copper clads and all that. So just a real mishmash of stuff. Not a whole lot, but enough. Somebody selling their K2 receiver there. Still wanted $2,000 for it US. So I think he had a K3 or K4 or something. No, that's a KX3. Sorry, KX3. He had a K4 already or something. So he needed to, I guess, fund the purchase of that. So, and of course, there's a couple hours of musical interlude. The musicians will break out and do some campfire-y kind of songs. It was kind of nice. Another station set up here with a KX3. So sorry, I had my terms wrong. It was a K3 that we were looking at on the table, the big box, of course. KX3 here with I believe that's the Elecraft portable antenna that the fellow was using. This was a vertical, obviously, nice, stable. I think this was set up with the K4. Don't know what the performance of it was like, but impressive looking setup there, tripod and all that. Carl, he's the life of the party. Always buzzing around, talking to everybody, and he's the first person to greet you when you show up at the event. So he's always a moving force in the event, and always has a little station where he operates CW. Apparently, he does this at every ham fest that he goes to in the New England states. He's a constant operator. So lots of swag from previous years. T-shirts, have evolved over the years. I guess Dave managed to swipe it off his head, but I don't think he came home with it. This fellow had a brand new Zagu 6100, I think it is. Had only had it for a week or two or something like that. A fairly new ham, but he had a inverted L, I think, antenna strung up into the trees, and was just sort of learning the ropes, so to speak. So there's our what's left of our roasted pig at the end of the event, I guess that would be the Saturday morning. That's the cook as well. Him and his son were the cooks. There's the lobster pots getting ready to be set up for the Saturday night dinner. That 10 by 20 tent is the Ladies Auxiliary Society that puts on the morning, full breakfasts, and there was a mussel dinner actually on the Thursday when we arrived too. So mussels Thursday, pig Friday, lobster Saturday. So you eat pretty well. There's Steve Weber again, seated in the jean jacket. This other fellow, I think he was originally from Quebec, but lives in the States now, Jim Frankenair. There's a up close look at one of the foxes in the hunt, of course. Bill, that was his name, Bill that was running that, Bill Noyce. Yeah. So just again, social pictures, lots of food, butter for dipping the lobster in. So we're getting into Saturday night. There's your lobster. I don't know how many there were all together, but people could have 2, 3 easily if they wanted. There was enough to go around, even enough to send with some people afterwards. So if you're into crustaceans, it's a place to be. I only had a claw, one of Dave's claws, my no thank you portion. So I did have a fair number of mussels on Thursday night, I'll say, in my non seafood defense. So there's Tim and his son, the cooks, Dave chowing down. Everybody enjoying themselves there again. Dave getting excited about his second or third lobster, who knows. Anyway, some stuff for the kids, as they had a raffle actually. Rex put this on, so Dave was happy with his big piece of copper clad. I had just my mini pieces there. And then I guess Saturday night, gathering around the campfire. There's Dave, one of the musicians, another Dave, another station set up there. Again, the ever popular Ellicraft radios. Sandy didn't come this year, so of course, got this sign, please come back. They wanted Sandy, not so much Dave, I guess, but they said I could stay home. So I don't know. It's just the way it goes. So, and I think this is the last slide. There's Rex mostly packed up with what he could cram into his van. I carried some stuff in my car as well, and we made it back to his place. We stayed with him overnight on Sunday before we headed back home Monday morning. Did it one shot, basically. Didn't pull into my place till around midnight or so. So it was a long day of driving, but anyway, fun nonetheless. So there you go. That was LobsterCon 2023 wrapped up for another year. So like I said, next year is year 25. So I don't know if he's doing anything special for it, but certainly a going concern. Some of the people over there said it's one of the best events that they go to from just a socializing and everything else point of view. So so there you have it. All right, so I will exit the show, and that's that.
Was this somebody's property or was it a park?
Thomas Point Beach and Campground, so private campground. It's been there for 23 or 22 of the last 24 years. I think the first 2 years were elsewhere, but no, they really enjoyed this place. So yeah, no, it was really good. So I see some hands are up.
Yeah, go ahead, Drew.
Yeah, thanks. That was really interesting. I'd never heard of this thing before. Your direction finding, was that on high frequency?
Good
or
question.
VHF?
Good question. I believe it was HF. I'm trying to remember. I know the frequencies were there, but what they were, Honestly, I cannot remember.
Did Dave build that DF unit himself, or was that something they had?
Oh
for
no,
everybody?
that was all supplied. Yeah, absolutely. Yeah. No,
Yeah, so it looks like it was HF. That's pretty interesting.
it was turnkey. Yeah, I'm just looking at the picture here. That I had that one. No, it doesn't really. I thought it. Oh, there it is. 3.58. Yep.
Oh, wow.
So 80. Yep.
Interesting. Thanks.
And it worked well.
Looks like a lot of fun.
It was like strong signals, and like when you're on top of it, it was almost you had to take rip the headphones off because it just overloaded your AF. So, yep.
Lots of fun. Thanks.
Yeah.
Go ahead, Frank.
Yeah, just a quick question for you, Eric. I didn't see any mention of him, but maybe in previous ones you've been, whether you run into a Dennis Mirandos, K1LGQ, whether he's been at that one or a previous one.
Yes, no, absolutely. He was definitely there. He's been there pretty much every year that I've been, and I know him well because he's always peppering me with medical questions. Found out that I was a pharmacist, and so he's yeah. I mean, honestly, he will corner me for like an hour, maybe an hour and a half, but that's him in the blue there. So.
Oh yeah.
Yep. What is it? His shirt says, "I can't keep calm. I'm Greek." So
we go back to the early 90s, I guess. I was introduced to him on the air when I was doing a expedition down in Bahamas, and I worked him QRP to QRP from down there. And then I finally met up with him at 4 Days in May.
Right.
And he used to edit the newspaper or the bulletin newsletter for the New England Club. And he conned me into writing an article for him, which I did, about the QRP from the Bahamas, I called it. So we kind of go back, and I remember he inviting me to LobsterCon, but I never got around to making it at all. But I'm glad to hear he's still there, still kicking, and that's great. Thank you very much.
Oh, yeah, you're welcome. Yeah, if you want his contact information, if you've lost touch with him, I have it. So.
Oh, that would be good.
Oh yeah. Okay. All right. I will make a note to send that on to you. So.
Okay. Yep. Thank you.
For sure. All right. Sorry, I'll just
go ahead, Pete.
Stop that sharing.
No, I was just going to say to Dave and Eric, they stopped off on the way on the trip here on the way to Kingston and had a coffee and whatnot, and they stopped again on the way back. And Dave brought me a present. I'm not sure. I think this is going to be Phoenix Generation number 3 on steroids on this board, but I'm wondering if that's why he bought all those boards. And
well, let's just say there's a story behind those boards. So when we went to Rex's, we got a grand tour. Like I had an abbreviated tour because Sandy was around in previous years of his, but we spent probably 6 hours going through his Quonset hut, 75-foot Quonset hut, and his basement, which is basically just a treasure trove. Organization needs a little bit to be desired, but let's just say Rex had a whole shopping cart full of those copper clad boards, like stacked, so like I'm not sure how many hundreds of them, but yeah, so plenty to go around. But anyway, it was nice spending whatever 3/4 of a day with Rex afterwards, one-on-one. So in the backwoods of Maine.
Did you guys do any operating, you and Dave?
No, other than my handy talkie, no operating. We were just shoulder surfing. Everybody that was there. I guess I should put my camera on. That would be nice. So yeah, no operating for us. I was thinking of bringing my Farhan's unit down with me that I picked up at Ham-Mention, but just didn't happen. So handy-talkie was all it was. So,
Did you get that radio working, by the way?
nothing since we've done what we did on field day. So.
Okay.
No, but I am doing a camping trip with Dave in August next month. So my plan is to find my little 7-inch portable monitor and maybe bring that along.
And which untuned antenna are you taking?
Probably a pack antenna, little thing shoot up into the tree. So I don't know. We'll see. That's the mind plan. That's what's on my mind's workbench anyway. So, as they say.
Yeah, very good. Very good. Anybody else?
Give you a little flavor of what it was like to be at LobsterCon. So, you missed Dave's commentary. That would have been much less kind to me, I'm sure. But you'll probably hear some.
We'd be all laughing.
I'm sure. Yeah. Would have been a little bit more of a Mr. and Mrs. Bicker.
Go ahead, Drew.
Well, I was wondering whether you left Dave in Quebec City as a result of your trip.
Yeah, I might have. That's not a bad idea. I could have, but no, I was kind to him. In his advanced age, I don't know if he'd be able to find his way home. So.
Cool. Very good. Peter.
For the fox hunt, did you guys participate in that as well, Dave? Like they had equipment to pass around to try if you wanted to try it, or how did that work?
I'd say there were about 4 units that were available, all operational. So, we each had our own, and we just had one between us, but because there were 2 or 3 others that were out at the same time, at least. So.
You brought an HF rig down with you to do that?
But no. Like he had units, turnkey units ready to go. So didn't have to bring anything other than work the dial basically. So you learned a few things about how that works and techniques and that. It's kind of probably a good sport for those that want a little bit of physical activity because
might be a good idea for one weekend at Eric's farm or cottage one day.
Yeah, not a bad thought. I mean, the equipment's simple, right? So, yeah. All right.
Anybody else? No? Very good, Eric. That was good. A couple of things. Our field day score.
Right. I actually don't have that at my fingertips, but and I was actually wondering a little bit afterwards. I did put down that we were operating solely on battery. I don't think we got any credit for that because I think you have to be 5 watts or less to get any bonus points for using battery. So. However, yes, our points are definitely submitted. So we got, I think, 100 for, it's 100. Why can't I think? 131 contacts. So multiplier of 2 because we were not using mains power, or was it the 100 watts? Low power, low operating power. So. 262, and then we got 100 points for battery, and then 50 points for submitting electronically. I don't know, whatever. Ended up being about 400 odd points in the end. So most of our contacts were on 40, less on 20 was our most of our contacts. 40, and then 15 was a smattering. So. I don't think we'll find out rankings or any of that until the end of the month when they tabulate everything. But it is submitted, and we're waiting for the next one. So,
okay, good. Go ahead, Pete.
You won't get the results next month. You'll be lucky if you get the results by Christmas.
Oh yeah, they take that long?
Oh yeah,
Oh yeah, October, November.
months.
Oh, okay. Sorry, I wasn't aware. I don't really pay attention to when they. I guess it's not till it hits the magazine, right? Or basically, yeah, yeah. Okay. Well, is what it is. So, I mean, we were running this, submitting our in real-time scores to a feature of the M3FJP logging software called Hamdash, and that gave you an idea of everybody that was using that same platform, and there were thousands, to see where how you're doing, and I think we were consistently in the top 15 or 20%, something like that. So it'd be interesting to see where we end up at the end, if there's any correlation
Down
to
the bottom.
what we were getting. But
It was
a whole lot more contacts in I think previous years with Park even. So
well, no, Park does way more than 130 contacts.
no, but just our station, like I don't know, did we do those kind of numbers in the past, Ken? Maybe.
I think we had a couple occasions over 200.
Yeah. Okay.
I would say we would have had more contacts if Hassan didn't keep falling asleep at the microphone.
And if we had resonant antennas.
And we had resident antennas. Right.
That's kind of helpful for these situations.
Thank God for auto tuners.
But we had nice warm ground all around us, and
The effective power output was probably about 3 watts.
the earthworms are so happy.
What else was there? Oh, do you want to find out from Industry Canada if we can get a club call sign?
Yeah, I thought it might be an idea. As I mentioned to Ken in an email, there's only, I think, 2 other Canadian stations that use the commemorative, CK, CJ, all that. So, and we were one of them. So, hats off to Ken for bringing that up as a unique thing to do. So,
Even though that one guy kept you busy for 10 minutes.
right.
talking about what
Did you ever get an email, Ken, from?
No, I never did.
No. Okay. All right.
Yeah, that guy kept going on and on and on. Wanted a QSL card because of the call sign.
Well, he's a prefix hunter, right?
Yeah.
Yep.
Yeah.
So there you go. Anyway.
Cool. Very good. Okay. I wanted to bring up something.
Uh-oh.
Actually good. I don't know if anybody else is interested. I was going through some old QRP quarterly magazines, and a few of them, they have the, what's that article where people said hints and kinks or whatever it's called? But anyways, there was a few articles brought up about the what do you call it? The box for capacitors and inductors. That one we built at the buildathon. I can't remember what it's called now.
What is it? What is it you're talking about that we built?
That little box for measuring capacitors and inductors.
LC?
Oh, the LC meter.
Yeah.
It's all digital.
Yeah.
This guy.
Yeah, exactly. Anyways, there's a few articles I was reading, and one of them was, I can't recall the call sign right now. He had built a little adapter to plug in there for measuring varactors, and I had checked the call sign, and I remember, I think it was about 4 years ago, maybe a year or two before COVID started. He had all the information how to make it, and he actually had boards for sale. I had purchased a bunch of them, and I was selling kits to whoever wanted one for $10. So if anybody's interested, I can make them available. I'll have to check what I have left, but it has all the parts, it has the board, it has all the information, and it's just a plug-in for the meter, and you could measure your varactors and whatnot on it.
Which issue of the magazine was that in, Ken?
Oh, I don't know. Probably early 2020, maybe 2019, something like
QRP
that.
Quarterly, right?
What's that?
QRP Quarterly?
Yeah, yeah. But I had when I saw this, he had posted it up on one of the uh, forums, and I contacted him and I told him I was interested, and he sold me a bunch of blank boards, and he also gave me permission to kit them and sell them. So I'll have to check and see how many I've got left. I haven't sold any for a while. So maybe what I'll do is I'll do a posting on our groups and uh, see if anybody's interested, and I'll have to find out what I have left over. And that's that. Okay, what's next here? So, has anybody got any show and tell? Something they're working on? Any comments about anything at all? Should we go do a round table of what everybody's doing, working on? Sure. I'll go first. As of late, I haven't been doing much. Uh, I had gone back home to have a funeral for 3 members of my family in Winnipeg. So that put a damper on most of what's going on, and I probably won't be able to work on anything till, I'm guessing, September, maybe after Labor Day. And after things smooth out there, maybe I can get back to doing some of the things I was working on before, especially the DCR. I'm at the point. I'm just working on the bandpass filter for it. So that's it for me. Okay, as I see on my screen, Drew, you're next.
Oh, okay. Well, good thing you called me. All right, so I just went down and got something so that I can do a show and tell, because you guys always embarrass me into showing things. That keeps me going and doing things. So bear with me for just a moment as I work my camera. And if I'm there, how do I turn it around?
Just hold it up. Whatever you're going to show us.
Well, I could, but it's much easier if, oh, there it is. There. There. Now, what I have here on my knee is a 9-to-1 Ballon, which was really interesting to wrap because I didn't use wires that are connected side to side. So I took a few unwrappings and wrappings, hence the kinks in it, but that's 9-to-1 Ballon. What I'm trying to put together here is a device I found actually on Thingiverse, and it was mentioned. This is the choke with, again, some pretty hokey windings, and a 3D printed box with a, all I have to do is get one capacitor put in there, 100 picofarad, and a couple of BNCs. It's a nice little QRP 9-to-1 random length end fed that I am hoping to have up in the air shortly. Now, a little tough to see, but anyways, so there it is. That's kind of what I've been amusing myself with. I haven't been doing an awful lot, but I wanted to kind of get this to the point where it would work. And very simple project. And I would suggest that for anybody who wants to learn about building antennas, this is where you start. The connections for the 9-to-1 are a little complicated. They're not quite as straightforward as typical. And it's, again, well worth the experience. Anyways, that's all I've got, Ken.
Very good. Very good.
I like the box.
Yeah, well, it was pretty cool. I mean, I like the printer. It works very well. And it just, you just punch these things out and everything fits into it. You got to be a little careful of the dimensions, but these are smaller toroids. This isn't going to handle a lot of power by any means. And I would suspect probably it's strictly QRP. But they say it'll do 100 watts. Now, you know, I'll get my FLIR camera out and we can watch the incendiary effects. Might melt the box. Anyway, that's all I got.
That'll make an interesting video. So please do it.
Yeah, if I can figure it, yes, I can do that. I can record the video as it slowly immolates itself. 100 watts out in the field.
But Drew, did you find a lot of those on Thingiverse? Was there quite a selection to choose from?
Oh yeah. Well, Thingiverse just the printing, but I'm trying to remember. I think I actually saw a video of it. Where did I get it from? I'll have to go back and look. I always forget and I never write it down. But I send myself an email, so I know if I go back in my emails, I'll find out where it was from.
Yeah. Now it looks like
it's just a random one.
Like
I'm sorry, go ahead.
The case is fitted right for that size of toroid.
Yeah, it is. Yeah, it's quite convenient.
Yeah, nice. Space.
And they're not big. I think they're 114s.
Okay.
The toroids.
Could have used that antenna at field day.
Well, yeah, you guys are having terrible trouble. I think you need a ground rod.
You need an antenna. That's all.
It always works. Well, I mean, how tough can it be? I'm really surprised to hear this. I mean, with all that gathered intellect out there and all the wire around, just throw wire in the air and throw a matching box on it.
Well, does wire have to be continuous, or can it have lots of breaks in it?
Well, actually, breaks are better. I find the corrosion really helps in the matching.
Okay, there you go. There's hope.
Most of my antennas are highly corroded.
Wait, were you joking or seriously?
Well, actually, Hassan, I'm only half joking. Some of my antennas are quite old, and I actually have to go out and sand off the ends occasionally.
Interesting.
The copper oxidizes to the point where, yeah, sometimes the ground connection isn't so good.
Yeah. I think the quality of the coax is another big factor.
I just lop the end. Every 5 years, you lop about 4 inches off the end and put a new connector on it. Don't bother with it. Just deal with it that way. It creeps down about 5 inches about every 5 years.
Yeah. Okay,
that's if you're in Kingston. If you're on the East Coast, it's a lot faster.
It's actually probably good advice is just putting new ends on it every so often, X number of years. So, yeah,
that's a rule of thumb.
Plus, I'm not known for my high quality soldering. So now that I have a 100-watt soldering iron, that's no longer a problem. But doing a PL259 with a 30-watt iron, it's a little questionable.
Okay. Thanks, Drew.
Sure, thanks.
Okay, next on my screen is Dwayne.
All right. Haven't been doing too much, with the weather and stuff like that, and trying to do yard work and stuff. It kind of gets in the way. I didn't make it to FDIM this year, but I did watch Farhan's presentation, and kind of interested in his FIDX23, his VHF, UHF version of the transceiver. But I've looked at the IF and audio strip that he's got for it, which can be scaled down in frequency to make a pretty much a universal IF strip audio stage for a HF transceiver. And I've been laying out surface mount boards for that, breaking everything down into modules so I can go and make small modules and put them together and see how they work, what kind of changes I have to make for it. Got the board just about all laid out. needs to get over and get out and etch some boards one of these days and put that together. Other than that, that's just about all I've been doing.
Yeah, very good, very good. Eric, been eating lobster and mussels, right?
Yeah, a little bit. Well, I'm actually pleased to announce that I did the other thing that I acquired, just to satisfy you, Peter, is, and I think you know this already, but I have a bunch of a couple transoceanic, Zenith transoceanics that I want to fire up, but I want to do it gently. So I purchased this off of Rex while he was down there. He had, I don't know, he was actually a little remiss about parting with this, even though I gave him some pretty good coin for it. But he called me about 2 days later and said, Eric, guess what? I was looking in my hut and I found another one. And it's not only this one, but it also has the meters on top of it, because I had pulled up an image of one that had a couple of meters, I guess, current and whatever else on the top. So he was, he was, that seemed to set him at ease. But anyway, so it's a nice portable unit. Apparently, you don't see them around all that often. I can't say I've seen any at Hamvention or anything, so probably now that I have one, I'll see one, on every table next time I go. But anyway, so start firing up my receivers, my old time receivers, and see how they perform. Common emitter amplifier circuit. So Dave spent a considerable amount of time, probably a couple hours on Friday or Saturday, going over that. So we were modeling it in LT Spice, that particular circuit, and talking about it in the drive and all that. So passed the time and learned a few things. I went a little bit too fast, so I'm going to have to review, but at least I've got a bit of a framework as to what the circuit is, what it does, and how it applies to things. So that's really about it as far as, and I guess that's really electronics, not ham radio in particular. But anyway, that's what is keeping me busy, other than making blinking lights on Arduino boards. So there you go. It's keeping me company here. So really exciting. I know. Yeah.
Should put it on the dining table and see what Sandy would say.
We had to say, right? Oh, it's so romantic, Eric. Yeah.
What, more junk? Very good, Eric.
Yep.
Next on my screen is Frank.
Turn the mic on there.
Yep.
And as I mentioned earlier, I haven't really been up to doing too much, but I'm happy to report that the completion of the HW9 from L is coming along, and I mentioned on last time we were on that I needed a shield for one of the coils. And I spent a lot of time trying to find this shield. And I finally got a hold of, did you mention it? I'm not too sure where I got it from, but there was a HW9 users group and repair, etc., out of a couple of fellows out of Vancouver, and it's an IO group. So I've just joined them, and I'm hoping to maybe find a scrap HW9 and somebody who's cannibalizing one, and I can find the shield I'm looking for. They're just not available in other places. So that's about it.
Okay, thanks, Frank. Next on my screen, Michael. Oh, Michael's busy. Oh, no, here he comes. Go ahead, Michael.
I'm here. I have nothing to report, so I'm just going to let you go.
Okay. Peter.
Okay, I'm kind of busy in the shack for a change the last few days. Actually, I was just about ready to configure the old Park SigGen into a controller for the Phoenix, and that went south because the my Phoenix board went deaf. Anyway, last few days I've been able to, or a couple weeks, I've been doing some troubleshooting on it and suspect there's an issue in the mixer area of the Phoenix board. But for comparison, I decided to repair my proof of concept board. So I because I took the transformers off of the proof of concept board and put them on the Phoenix board. So because I knew they worked. And if I had a problem with Phoenix, then I knew it wouldn't have be the cores. Anyway, so I rerouted some new cores, put them on the proof of concept board, and then I had to do a couple of different repairs for it's an outboard audio amplifier for Phoenix, which duplicates the Phoenix board. I actually didn't realize it, but I let the smoke out of a resistor on the audio amplifier board. So I was disappointed that I didn't get to see anything, but it took me a couple of minutes to figure out where that open was. So I did that. In the process, also, I acquired a LT Spice model for the 612. And because on my proof of concept board, I get a little bit of gain out of the first mixer. On Phoenix, I don't get a gain. I get a fairly substantial loss. I think I alluded to that on the last meeting. So I got a Spice model because it's time to start splicing this stuff. And sure enough, the Spice model does show a gain, and it comes pretty close to matching the gain that I experienced on the proof of concept board. So that's pretty much all I've been up to. I'll probably this week sometime I'll go down to Dave EAC and pick up his active probe that we just mentioned just prior to the meeting starting here, and then I'll put the active probe through its paces on the Phoenix board just to duplicate what I've done here and just see how it performs. Hopefully that it works out well, because it's a fairly simple circuit with some pretty common parts, so it shouldn't be too difficult of a build. And thanks to Dwayne again there, he's going to send some Gerbers and whatnot for it, so that'll look forward to that. And I think that's pretty much it from my end. Ken, thank you.
Did you ever figure out what was going on with your receiver at field day?
That's what I was talking about. I've troubleshot down to. That's what I had the last meeting. Oh, you weren't at the last meeting. I think the issue is the first mixer is showing a sign of the output is way down. It's about 30 dB down, whereas on the proof of concept board I get about an 8 dB gain. So there's something going on there. Now, what is it? I don't know, because the next in the line in the chain is a transformer, and that transformer is fine, or it was. And that's the other thing. The Phoenix board worked before I took it to Dayton, so it sort of sounds like the signal's grounding out. But because I've changed the mixer, and that didn't make any difference. Anyway, it's at least I'm confident now that that's where the problem lies.
Is the LO signal level?
Oh, that's another point too. Actually, I since discovered that yeah, I think there's a problem there too. I think there's an issue there, but the part that throws me off, nothing has changed from the time when Phoenix was working. Okay. I suspect that the LO is too low, but if the LO today should have been the LO of prior to Dayton when it worked. Yeah. Nothing's changed yet, except that it doesn't work.
Are they Chinese 612s?
Probably, but who knows?
Okay.
Yeah, I brought them around. They work in my proof of concept board. See, that's why I rebuilt the proof of concept board, because I wanted to go back and because I knew it worked well, and it is working well.
Yeah. So I think you watched that video of Alan's. He was a.
Oh yeah, I had a little exchange with him as well.
Yeah, you can see that it does. It does. There is gain, a lot of gain.
I don't know how I missed it. I have to go back and take a look and see why there's a gain there. Because when I first looked at his video, I looked at it. To me, it showed a loss, but he says no, there's a gain there. So I have to go back and take another look.
Yeah.
Yeah. But at least But I've got that LT Spice model that shows a gain, so that was pretty good.
Yeah. Okay.
Yeah.
Very good. Bob, good evening. You're next on my screen.
Evening. Let me see. Get a video here. Okay, I've not been I've been on the road since last meeting. I've been on the road for 3 weeks, so I've not been radioactive. I think last meeting I mentioned I'm trying to find a USB port sniffer, and someone did give me a recommendation, but I was too cheap to spend $60 to buy it. So what I'm working on is trying to learn a little bit. I found a Python book at a garage sale for $1. So I'm going to learn. There's something in the syntax that I've gotten wrong in my IO generated code for the sniffer. So I'll get it resolved and learn a little bit about Python again. And someone showed a 9-to-1 Bellin, and thank you for reminding me. I had wound one, and I wanted to put it in a small plastic dental floss container that I saw. What's the fellow? GOAT. I forget the full call, but he does this mountaintop QRPing. So I wanted to do that because I generally, if I'm in the field, I'm only operating 5 watts. So that's all I've got to say for now, and I'll see you guys next month.
Very good. Thanks, Bob. Next up on my screen, Mr. Sleeper, Hassan.
Hey, okay. What's on my bench? Nothing right now except the bench itself. I'm refinishing a wooden table outside, and I'm beginning to think it's so much fun. I actually might get interested in making wooden cases for my radios. So that's where I am right now.
Oh, good. Cool. All right, and last on my screen is Mr. Kevin.
Hey guys. Well, it's not been that nice, but it's been summer, so I've been doing summer stuff instead of radio stuff. So whatever was on my bench, namely like a Pi or a pet computer and stuff, well, it's still there, just it's feeling kind of lonely. So that's about all I've got to say.
Okay. All right, thanks, Kevin. And I think that's pretty much it. Anybody else have anything they want to add quickly? No, we're good. A little after 9 now. Okay. Gentlemen, our next meeting is that the 2nd of August, I believe? Yeah, it is. Unfortunately, I won't be here. I'll be camping. So, and there's no way I can get a decent signal over there to jump in. So, good evening, everybody, and we'll see you on the 2nd of August. Have a good evening and have a good weekend.
All right.
Good night, all.
Hey, 73 to all.
Yeah,
Good
night.
Okay, thanks for that info, Drew.
Well, I was going to say, Eric, if you want to hold on for a second, I can tell you what I did.
Sure, yeah.
I couldn't type fast enough. I'm doing it on my phone, you know.
Maybe
So
I'll
I
keep the
built
recording going.
Okay, this is a 9-to-1, and it's intended for an end-fed random length
Random. Okay.
antenna. And so the random length is specifically not any half length.
Right.
They're very keen on. There's actually a table of lengths to use that avoids it being an actual half length. But the 9-to-1, you take 3 wires and you make sure they stay parallel to each other, and you wrap them 9 times. And
Okay.
then there's a nasty crossover thing. If I can find it, I've got the diagram for how you connect it. And it's not hard, but it's like the outer one to the middle of the 3 on the one that underlaps.
Right. You
So
just have to make sure you
it's
do
not
it
horrible. Anyways,
carefully.
yeah, there's a very specific way you do for the 9-to-1.
Right. Right.
And the 1-to-1 choke is just coax.
Right. Okay.
It's just
But it ends
316
up being a
coaxes.
49-to-1 Ballon in the end, though, right?
No, 9-to-1.
Oh, just 9-to-1. Okay.
No,
Just because the description in the Thingiverse talks about
yes,
49. So
that's true. And interestingly enough, if I used, I have actually made a couple of 49-to-1s, but this one is not. You're right. The cover and everything else is meant. It says 49-to-1 with a choke.
Yeah.
And yeah, that's what it was intended. It's to fit the FT 140/43 cores.
right.
That's what this one's built for. I just printed it out because it was kind of close to what it fits for me.
Right.
And so I wanted to build a 9-to-1 because there's another thing you can make with a 9-to-1, and it's called a terminated end-fed dipole.
Okay.
And the terminated end-fed dipole is what I have been using for years. I have a big version of it. It's I was going to say Bang & Olufsen, but it isn't. It's it's B&W. It's called an ACS 1.8-30, and these antennas they're military antennas. You can't buy them anymore, but I bought this before 2000, and it has a 9-to-1 on one end. It has 102 feet of copper that is mounted so that it's got a triangular section. So it's basically an apex of 40 feet and 102 feet separated, so 51 feet each side of the apex.
Okay.
You have a 450 ohm resistor on one end, and you have the 9-to-1 on the other end. And so you have the antenna in a triangle, a delta configuration, and then you join the ground to the ground of the coax. So you have this wire going along the bottom to form the bottom of the triangle.
Right.
And that's connecting the ground to the ground. And then the antenna section is in a big delta configuration.
Right.
And essentially what you've got is a 450 ohm dummy load, but it has a radiating wire in it. They're not terribly efficient, but they match 1.8-30 easily. And I've been using one here for about 25 years. And no matter what, it matches. So I can even work 1.8.
Huh. And if you're saying how tall is it? What's the apex at, roughly?
Well, the apex is supposed to be at 40 feet, but I have mine at about 25.
20. All right. Okay. So pretty modest. Yeah.
Yeah. Oh, yeah. No, it's not a big deal. The nice thing about it is it's got a nice, it matches, right? I got it because it matches all the bands. You don't have to worry about playing around.
Right.
And I can flip you the plans for a terminated end fed. There's a lot of guys making them.
It's called a terminated
terminated end fed dipole. And you'll see it abbreviated as TEFD. Palomar Engineers has one, but I wouldn't recommend you. I mean, I bought a couple of 100-watt, 450 ohm resistors off of DX Engineering because they have a Canadian outlet now.
Right. Okay.
So I picked up a couple of these 450s, and this is my experiment. I'm going to put 102 feet of copper in between and see if it'll work. I saw that QR. I didn't realize you were at a QRP Radio Fest. That was pretty cool.
Yeah, the LobsterCon. Yeah, it's definitely a I forget if it's billed as New England's premier QRP gathering, but yeah, it's definitely I guess QRP meaning up to some people had 100 watts going there on their on their bigger rigs, but most of the people were, 5-10 watts that had rigs. But again, it wasn't really an operating event. It was really meant just for socializing and chatting, and sometimes it was radio stuff, sometimes it wasn't. So, but no, definitely a fun event. So, it's
a lot of the QRP guys are using the end-fed half waves, but
right. Yep.
I bought a couple of radios off a guy. He designed this thing, DL2 MAN. He designed it off of the QCX.
That's
And
that true SDR or something, isn't it?
That's the one.
Yep.
So I got a couple of these things, and I buy them off of Sunny in I forget where she's from, in China somewhere, but they arrive in perfect shape, and they arrive in about a week. And this guy Manuel, he uses these end-feds, but he tends to use. He has been using the end-fed random length.
Okay.
And they do very well with them. So I was a little surprised the QRP stuff there that they didn't have longer antennas. A lot of them were using pretty small, kind of not great antennas.
You're talking about at the event I was at?
Yeah. I didn't see a lot of wire.
No, there really wasn't. Like I said, verticals. Well, there were a couple horizontal, like what is it? Like I said, the inverted L's, and but there wasn't really a whole lot up in the trees. One or two, maybe something like that. NFEDs are the half wave NFEDs are seem to be the antenna du jour.
But you're kind of limited too. I mean, I built one, and it is, you can work the multiples, but you can't work in between.
Mm-hmm.
And the 1.8 to 30, I found out my radio works 60 meters. I didn't know that.
No,
it's an old 706 that I guess somebody opened up.
Right.
So I can work 60 meters FT8, and I use my my terminated end-fed, and it matches right to it. Bang, no problems.
Huh.
So that's the convenience of that design for me. Is I don't have to worry about it. I just hook it up, and its match is going to be pretty well bang on.
Right. Well, that's my challenge right now. Is I don't have a decent resonant antenna of any sort. I got to go one step back and look at my either analyzer that I have or the Nano VNA just to see if I can get some reliable data coming out of that. I'm not confident. I don't know if you heard about our field day travails, but
I didn't. It didn't sound positive, but I'm not sure what happened.
Yeah, we made contacts, and people were able to hear us, but they certainly, we were having matching problems, 3-to-1s that the radio was having to deal with, and the tuners were absorbing a lot of the energy, I think. But these are antennas that I've used before without much of a problem, and one of them is a commercial LNR.
Right.
What is that? The PAR NFED. I think it's called NFEDs.
I think Phil's got one of those.
Yeah, and it's worked fine in the past. So I got to check, continuity and everything. I took the box apart, which had some moisture in it, which probably didn't help. But I dried it thoroughly, reassembled it, and still it's kind of exhibiting the same behavior. So whether there's
if it's an end-fed, has it got a capacitor in it as well?
Yes, it does. Yeah, absolutely it does. Yeah.
A lot of them put 100 picofarad, 2,000 or 3,000 volt capacitor across the leads.
Yep.
And do you think maybe you might have popped the capacitor?
Is that a possibility? I guess. Yeah. Didn't even think of checking components, but that's maybe not a bad idea. Have a look at that. I mean, obviously. Sorry?
When I built my end-fed, I go up on the roof a lot. So I just went up on there and had my son stand down at the box, and I would just fold back the end of the antenna, and then starting from there and using the Nano VNA, figure out whether it's too short or too long, and just keep lengthening it a couple of inches at a time until it matched up. So I matched the antenna to the situation. All these theoretical lengths they give you, oh, it should be 66 feet and all that stuff. Yeah, that's great to start with, but I've never had an antenna match the way they say it should because local conditions are different. But I built a fan dipole years ago, and each one of them is a matched dipole for the specific frequency. So I have 20, 15, and 10, and 6. As you add a band, of course, you're going to, play around with them a little bit. But I only use chunks of PVC pipe to separate the dipoles from each other.
Okay.
And it looks really terrible. I mean, you look at this thing and it looks very, very homebrew. Works like a champ. It's utterly matched at 20 meters and 10 and 15 and 6. And it has never moved. And I basically made it out of speaker wire.
Right.
So, I don't put a lot of effort into this, but you might want to try you might want to start with a straight dipole on 20 and maybe 40. And see if you can get them to work. Because
Right.
I'm beginning, you won't, on a continuity check using DC won't tell you if there's an RF problem.
Yeah, well, I'm just looking for, possibly breaks in the wire.
Yep.
I mean, I know it's a long shot,
Of
but,
course.
anything along those lines. Because I have an 80-meter inverted V horse fence antenna. And same
Yep.
thing, we were having matching problems with it. It's worked fine in the past. But, I picked up this rig expert back at Hamcation in February. And first time that it's really been put through its paces. And it was failing its self-check mechanism, like it was throwing out error messages on its self-check routine. So I'm not even sure about its validity. We were using it to look for resonance as we were, trying to troubleshoot. But, a bit of a lesson learned there is not to leave it till the morning of field day to be checking your antennas, of course. But
that's the real world.
Yeah.
That's the real world.
Yes.
Do you have a manual tuner?
No, something that has
Yep.
like that
Knobs and dials and a big honking insulator on the back that you can just
Right.
pull long wire on.
Yeah, no, unfortunately, I do not.
Sometimes that's the best way to go. Is first you get something working, and then you try to find. It sounds like you have a grounding problem.
That's possible. We had counterpoises set out for the NFIT half wave, which depends on who you listen to whether that's needed or not, right? But didn't make a difference either way. So
no.
So
and the Nano VNA, when you put it on SWR and did a sweep, was it minimizing on any frequency nearby?
Well, all we used was the rig expert, which I guess is basically the same thing, right?
Well, I don't know about the rig. I've never used one.
Yeah. So we swept
Nano
it there.
VNA, you can sweep the frequencies. You can jump bands. So you just tell it to go from like 3.5 to 14.
Yeah.
And see where it might be sending peaks and valleys to you.
Oh yeah, so the rig expert definitely does that. You can sweep any frequency you want at any resolution, and I think it was hovering around 6 megs or so. When we were trying to tune for 40, and it didn't matter how much we shortened it. We were starting to shorten it by a foot, 2 feet, and it was barely budging, where you're supposed to just do minimal. Now the way we were shortening it, we weren't afterwards realized that you're supposed to bend it back and wrap it around itself. We were just kind of coiling it. Which you're folding it back.
Oh, you coiled it.
So we were coiling it.
Oh yeah, no, you can't coil it.
Yeah.
Coiling is a bad thing.
Yeah. So learn these things kind of after the fact, but
That's fun.
Yeah, exactly. Whatever you learn, you only learn when you make mistakes, right? But
let's face it, nobody's bleeding out on the table, so it's okay.
Yeah, exactly. Yeah, and like I said,
the fun thing is, did you get a good RF burn off of it? Did you get a bite off of it?
Nothing.
We used to do that all the time. We would go out in the sticks, do these little Aries things, and the guys I was with were ex-World War II guys, right? Mm-hmm. So they just threw as much as in the air. There were no grounds anywhere. and we had metal microphones.
Right.
So you got a real good lift off of that. And Bernard just going to laugh at you and say, well, just throw more wire on the ground. So
Yeah.
we just threw a lot of wire in the air.
I've only had that experience once, and that was when I had my radio in the basement here, and then I just had the end-fed half-wave wire going out the well window into a tree, basically. No ground wire, no nothing. And every time I keyed down, not only would I get like on the paddle, I would get a buzz on my hand, but the central vac would turn on as well. So I think there was a little bit of RF straying around.
On 15 meters, I make the bass speaker in my sound surround for the TV. It hums. So every time I'm on FT8 on 15 meters, there's this low 30, 20 hertz hum comes out of the radio. Oops. Oh well. Nobody's noticed it but me so far, so I'm lucky. Right. But really, when it comes to that sort of antenna confusion, I tend to go back to change the coax, stuff like that. Just flip out the coax. Sometimes a coax has something in it that's not happy, and it takes forever to find it.
We were substituting coax. Like I had some, and I had some like LMR 400, like decent stuff, not old, like maybe 2-3 years old. Then we subbed in some RG8X, I think it was, thinner stuff. But it didn't matter what we did, we could not get the matching to be even close. Like we would have been happy with a 2.5 to 1 or something, or 2 to 1, or like.
Do you have a dummy load?
Kind of, but I've got the wrong connector for it. I know.
Okay.
So the bottom line is not.
Sometimes it gets to the point where I will put a dummy load on it just to make sure it's not something in the radio.
Yeah.
I know what you mean. That's very frustrating, but I have a manual tuner, so worst comes to worst, I can force it. Right. I mean, my affected radiated power might be in the milliwatts, but at least I know it's working. Mm-hmm. And the current system that I use, I have an LDG tuner on it, an auto tuner, on an old ICOM. The old ICOM, the max it can put out is 50 watts. It's kind of had its day. So I run that through the LDG and into this terminated end fed, which doesn't have much of it doesn't require much matching, but every once in a while it needs something, especially when the corrosion starts to get around the eye bolts. Right. And on that, I've hit South Africa and the far end of Australia.
Wow. Okay.
Yeah. So it these things work. I know it works. I'm not getting much response lately, but I take a look at PSK Reporter and I know I'm getting out.
Right. Yeah.
And I use that as a direct indication of how it's working. And that helps a lot in terms of just making, comforting yourself that you've done it right. The match is okay. Yeah. It's the other people that aren't answering it.
Right. Like I even, after field day, I participated in the rack contest on the 1st of July. And I even reoriented I assumed that the end fed half-wave radiates off the sides. So I had it basically east and west, trying to get Canadian stations. And I even suspended in the air, like the end of the, where the matching box is. And oh man, that was so disappointing. I think I made 3 contacts on the Canada Day contest. It was just so and they were a struggle to make them too. So I know something is up. So anyway,
do you use FT8 at all?
No. The short answer is no.
Well, I just wondered because digitally, if you do any digital at all, and PSK31, anything digital at all, you can tell from PSK Reporter how you're doing.
Yeah, what I usually...
I've never been much for the reverse beacon because I don't send CW clearly enough for it to recognize me.
Oh, okay. Yeah, because that's actually what I do normally is I just send reverse beacon and use the iambic paddles. And, in the past, I've gotten all kinds of, hits. And, I'm still getting some. I mean, that punches through and, I get the reports but it's certainly not like it used to be. So again, something fundamental has changed in my setup here, and I got to just get to the root of it, figure out what it is. So where, like you said, maybe it's a grounding issue or
same radio.
Yeah, it's the 7300, right? Which is
So
not
with the
old.
7300, and it's telling you it's putting out a full 100 watts.
Yep.
And do you have an SWR meter on it?
Yep, it does. And, you know,
it's showing that, and the meter agrees.
Yeah, the meter agrees.
So that part's good.
Yeah.
And then you changed out the coaxes, so that part's good.
Right. Although I do want to run like the Nano VNA or maybe the Rig Expert on the coax, just, you know, because I know it can do some tests there. But like I said, I think step one is validating the Rig Expert, you know, its actual function, whether it's, you know, because this is the first analyzer I've ever owned, you know, and, you know, spent any real time with. So I got to make sure it's working properly. So do a little troubleshooting there and then start, you know, once what I'd like to do maybe is head down to Al Haynes, who I borrowed the Rig Expert, and just to compare, like, because he's got a similar model, just, you know, head to head, see if it comes up with the same readings on a given antenna, right? You know, have a relative.
You said it failed its self-check?
Yeah, exactly. Yeah. I had some self-check routines that, again, after field day, I started running these things, saying, like, you know, because I wasn't using I was just busy stringing wires up and all that, and then, you know, like, Sunday afternoon after field day's done, I start, you know, getting into the, you know, how does this analyzer work? And I know there's
do you have like a 100 ohm resistor you can put across the leads?
Yeah, there is a calibration kind of thing that you can go through to, I think it's intended to compensate for you know, situations, but, you know, there's like an open short and there's some standard process, open short something.
So it's like a VNA.
Yeah.
This thing's got all the 50 ohm load and then the open and the short and the. See, I was just thinking if you just take an ordinary resistor, like a 50 and a 200 and a 100, and put it across the antenna leads on the analyzer, see what it comes up with.
Right.
That way, you know, it's one. It should be 1-to-1. It should be 2-to-1. It should be 3-to-1. If it's not telling you that, then your analyzer's not good. Right.
And so what values of resistors do you put across for that 1-to-1, 2-to-1, 3-to-1, like 50, 100?
50, 100, 150.
That's it, eh? Yeah. Okay.
Yep. And carbon, it doesn't matter. You're not putting any power through it anyway. It'd be better if they're carbon resistors.
Right. Okay.
And just see, I mean, it should tell you that. That's basically what the calibration stuff is for the Nano VNA.
Okay.
Is you get a 50 ohm resistor and you put it across the end of it, and it tells you, yes, this is 1-to-1.
1-to-1. If it's something else, then
you got a problem.
Your device is suspect. Yeah.
And I like the Nano VNA because it'll sweep from like 0 to about 30, and you can see where your antenna's working and where it's not.
Mm-hmm.
And I was surprised that my end fed, which is cut for 40, so it's 66 feet long. What did it work on it that it wasn't supposed to? I think it was 15. Turns out it matches on 15, but it shouldn't. Okay. So that the Nano VNA gives you, well, it of course can do a great deal more than I have any idea about, but I use it as a really whiz-bang SWR meter for my antenna.
Right.
And that's why I do the sweeps on it. And I often will set up my tuners so that, you know, if I'm not getting a tune on the antenna, I can force it with my matchbox. I can put everything through the matchbox, and then it'll work.
Right.
And I can tune it using the VNA and just watch it and type in the inductors and the capacitance and watch it drop. I trust it more than the SWR meter on the matchbox.
Right.
Which I have to watch because these little QRP rigs I have, if you put them into a mismatch, they blow up.
Okay. All right.
They're really touchy that way. Everybody warns you, don't go over 2-to-1 or you're done. And several guys have reported the QCX is extremely sensitive. The one that comes from, is it Farhan or?
Helen Summers, the QRP Labs, I think. Yeah.
That's the guy. Apparently they're very touchy for SWR.
So if you don't have a resonant antenna, you can do some serious damage to the radio itself.
Yep.
Really? Okay.
Yeah, some of these little QRP rigs aren't geared to dial back like the big rigs are.
Right. Right.
So when I read that, the little DL2MAN one I got, the little True SDX thing, they warn you, do not play around with this. Don't go over 1.5 or 2.
Right.
And
but I mean, how would you even like? I mean, would it give you a warning? Like, you know, let's say you have nothing.
No. Apparently, it's a poof.
Wow. I mean,
oh yeah, no, it's really like I've been reading all these horror stories on the web. I'm going, well, that's encouraging. So now I'm building a match. Well, you can't even measure SWR at that power.
Mm-hmm.
The meter won't read. So you got to use something else to match the antenna, and then you hook the radio up to it.
And oh wow, okay, I didn't realize.
Oh yeah, like it's touchy. I was looking at this, and I went, well, that's why I'm building a terminated end fed, because once I build it, I know I'm fairly safe.
Yeah.
It has been essentially 1-to-1. It's not anymore. It's kind of drifted a bit at the 1.8 level, but it's 1-to-1 from 80 meters to 6.
Right.
It doesn't move.
No.
So that way I'm safe. I won't blow up my QRP rig.
Yeah. Okay, well, you kind of answered a question. Like, I was wondering, like, you know, how much power do you actually have to put in to measure SWR?
Well, you need more than 5 watts, because I know that my little 5-watt thing, it actually moves. It actually moves the SWR meter on my Matchbox, but I don't know how accurate it is.
Right.
So I actually bought I bought a QRP SWR meter from Dave Cripps, NMOS or NM0S.
Dave Cripe, yeah.
And it was a cute kit, you know, kind of funny, but it measures 0.5 watt. So when I put a 0.5 watt out, and it'll tell me.
Right.
And the True SDX puts out 0.5 watt if you feed it with a micro USB cord,
right,
instead of a standard battery. You feed it 5 volts and it puts out 0.5 watt.
Right.
And you can't blow it up at 0.5 watt.
What's its maximum power? Is it 5 watts?
Oh, 5. Yeah, 5 or a bit more.
On 13 volt or whatever, I guess.
Yeah, you feed it. I feed it with 3 18650 batteries.
Okay.
So that's about 12 and a bit.
Right.
I know also with the True SDX, it's more tolerant of a slightly higher voltage, but you still got to keep around 12. And I know the QCX.
Right.
That's the one Howard was talking about. If you build it for 9 volts and feed it 12, it's done.
Yeah.
Blows up. So I need these QRP kit rigs. They're a lot fussier than your standard commercial.
Yeah.
You know, this old ICOM I got, I'm pretty sure it's been kicked down the stairs 20 or 30 times before I bought it, because it's looking pretty ragged, but it doesn't care. It just sits there and keeps working.
Yeah, that's why it's nice to have a little, bit of both, right? It's nice to have one you can just pull out and it just works, right? So,
I've got too many of them, but I would look into, I don't know what to recommend. That's such a perplexing system you got up there.
Yeah.
Weird. You need to take your end fed somewhere else.
Yeah, maybe that's a thought as well. I have used it in many places as well. And again, it's a multi-band. It's a 10, 15, 20, 40. So, it's got little tuning stubs hanging off the wire and all that. But I think there's, like I said, it's either with my measuring equipment or the feed line or something, grounding. There's something.
Did the 7300 also tell you? When you hook it up directly to the 7300, did it tell you there's a problem?
It complains. Oh yeah, absolutely. If I check the SWR, it's all over the map. So yeah.
So that sounds to me as though it knows what it. I mean, I'm inclined to think that I would go looking. Well, to start out, I would open up the box, and I would look for any connections that might need to be resoldered.
Yeah.
And I'd be inclined, since you have stubs hanging off of it, and each one of those, the long wire and the stub is the antenna for, say, 10 meters, and then the next section of the long wire and the stub is the section for 20 meters.
Right.
How are those connected at those joints? Are they soldered in, or how do they do it?
I think they're just, they came factory, but it's got some little kind of clip-on connector that probably just pierces the insulation, I'm guessing.
Okay.
It doesn't
That
look
seems to me to
soldered.
be the weak link.
Yeah.
I would hook up a standard dipole to it and see if you can get it to work.
Okay.
Well, you said you have an 80 meter that's not working, eh?
An 80 meter inverted V, but again, that's old. I've had it for maybe 10 years. I've never done any maintenance on it or whatever. So again, just straight continuity checks on the wires, make sure everything is solid there. I mean, it's been hanging in the air for a number of years. So, and yeah, actual horses running into the horse fence antenna. So, it's possible something might have come loose out, but I mean, it doesn't look deteriorated. So, there's nothing that's obvious or that's really visible. But actually, I did take a picture of the inside of the box of my end-fed antenna. And I mean, that's the capacitor there.
Oh, yeah.
It's fuzzy, but I guess the only way to really check that is to take it out of circuit and put it on an LC meter, I guess. See what.
Yeah, you can put it on an L meter, but it should be 100 picofarad marked on it.
Oh, yeah. I don't know off the top. Sorry, I know it's kind of fuzzy there, but anyway, that's the sole cap that's across the leads in the matchbox.
There's really not much to them, is there?
No, other than
once you take these things apart, you get upset because you spent a couple $100 on this thing, and it's an empty box with a capacitor and a hokey coil in it.
Yeah, it makes me want to start making boxes and selling them at Ham.
Well, I got to tell you, I started to look at the prices, and I said, I can do this. So I ordered up some random toroids from Palomar, and now I'm getting some from DX Engineering.
Yep.
And I watch a couple of YouTube videos, and I'm building them to see what's going to happen.
Yeah. I've heard that comment before. Like, why would anybody buy an antenna? Just doesn't make any sense. There's not that much to any antenna, right? It's just either wire or tubing and connectors, basically, right?
Well, Peter's got a pretty good one. He's got an off-center fed, and that uses a 4-to-1.
Mm-hmm.
And there's two versions of it. One is 1/3, 2/3 with the ballon at that point. And the other one, I think, is 1/4, 3/4. Okay. And there's great schools of thought between the two, but I'm talking about a pretty simple setup.
Yeah.
So I actually have a 4-to-1 I'm going to try. Now, the thing is, they're long antennas. I think you have to cut them for 80 meters.
Okay.
And so that's a lot. That's like 125 feet long or something. So I'm not sure I got the acreage for it.
Yeah.
But it's one of those things where I want to try it because everybody I've talked to with an off-center fed, they do really well.
Mm-hmm.
And you can use those as an inverted L.
Okay, right. I think Peter had one of those last year when he was here for field day, and an off-center fed. So
they work really well. And if you can put it as you put the ballon basically at the corner and drop the 25, drop the 25 or 30 feet down, and then you shoot out the 90 feet. You've already got a lot of wire in the air, to be honest. It would be hard not to get somewhere.
Right.
I mean, that was always the wisdom given to me, is just throw a bunch of wire in the air. But these are from guys who had these massive matchboxes.
Right.
Current day, you can't do that with a 7300. They're pretty intolerant of anything over 3.
Right.
Most of the modern rigs, nothing over 3 for an SWR, so you need another matchbox just to make them happy.
Yeah. Well, on field day, we ran everything. Ken brought his LDG AT200. That's what we were running everything through. We basically just turned the tuner off on the 7300. So, because it can handle a higher, and I think that's what saved the day, basically. So, for us, and otherwise,
it won't match anything.
Yeah. So, But anyway, all right. Well, thanks for the advice, Drew.
Well,
Gives me a few
it's good
thoughts.
talking. I'm not sure how much advice it is, but it's good talking this stuff out because that's how you figure stuff out.
Right. Yeah, for sure.
Yeah. Well, good luck with it. I'd be intrigued to hear what the end story is. There's going to be a punchline to this story.
That's right.
Exactly. It's
Exactly.
going to be like your horses were doing something to you.
Yeah, exactly. There was a piece of hay stuck in the the connector on the back of the radio or something like that.
Exactly. Exactly. All right. Well, take care.
Yep. All right. You too. Have a good night. Thanks, Drew.
Right. Good night.